Hello everyone and welcome to the part 18 of this Amazon Bedrock AgentCore series. In our lab today, we will build a real-time dynamic weather agent using Docker, Lambda, LLM, OAuth, AgentCore Gateway, Secrets Manager, Cognito, and OpenWeather API. I have created playlists for Bedrock as well as AgentCore on my channel. As I create additional tutorials and labs, I will have them added to these playlists. Source code for this lab is available on GitHub. This is the link to my GitHub repo. This is a public repo. And if you go to this repo, you will see part 18 along with the other parts over here. This is part 18 right there. And if you go inside, this is the entire source code along with an architecture diagram and the lab scenario that is available over here. All of these URLs will be mentioned in the description of this video. Scenario for a lab today. So as I mentioned earlier, we will create a real-time dynamic weather agent using all of these services. So what are we tasked in this lab for? You are tasked with building an intelligent real-time weather assistant that can interact with the users using natural language. This assistant must determine whether a user's message requires weather information or is a general question and respond appropriately. The agent is built using Amazon Bedrock AgentCore and leverages a large language model, essentially a LLM. It uses this LLM to reason over user input and decide when a tool invocation is required. So in very simple words, you are building a weather assistant that uses a LLM behind the scenes. It basically gets the user input, it analyzes the user input to determine whether it requires weather information to answer the user's question or is it a general question. If it's a general question, it'll simply just go ahead and answer the question. If it determines that, hey, weather information is necessary for me to respond back to the user's question, it will then invoke a weather tool. When I say it will invoke a weather tool, essentially it will basically return a message back to the agent saying that tool invocation is necessary. And the agent will invoke the tool, get the data, and give it back to the LLM. The LLM will then use that information to respond back to the user by creating its final response. So this is overall what we are going to build today. So some of the key parts or the key components of the solution are an AgentCore LLM. Remember, this LLM has to interpret user's query and dynamically decide whether to invoke a weather tool or just respond to directly using the model. We are also going to do dynamic gateway tool discovery. So in the previous labs, we used to run a utility to basically get the tool name. Now we will dynamically discover what tools are available in this particular gateway. And then we will basically invoke the right tool, in this case, the weather tool, to get the weather information. Then along with that, we will use OpenWeather API. And of course, this OpenWeather API is going to be invoked using Lambda. So no mock functions. This is the real deal. Our Lambda is actually going to call the OpenWeather API. It is a free tier API that anybody can use and get the real weather information. secure secrets management. So all of our API keys, these API keys are for our weather API, our OAuth credentials, as in like a client ID, a client secret, token URL, scope, anything and everything that is required to get an OAuth token, everything is stored in Secrets Manager. OAuth-based authorization. So earlier we used to create an OAuth variable, but now we will dynamically fetch the OAuth access token using these client credentials that are stored in AWS Secrets Manager. And by that, we will basically not hard code anything, okay, and authenticate securely with AgentCore Gateway. So fetching the OAuth token dynamically and basically authenticating it with AgentCore Gateway. And last one is Dockerized runtime. Essentially, we are going to create a Docker-based agent. By the end of this lab, you will have built a production-style intelligent agent. This is the key. So no hard coding, no mock functions. Everything is dynamic. Tool discovery is dynamic. Tool calling is dynamic. OAuth authentication is dynamic. Okay, LLM dynamically decides whether to call the tool or not to call the tool, and then hands that over to the agent for tool calling. So everything in this end-to-end is real-time and dynamic in nature. It simulates the way you would actually create a production style weather agent, which is an intelligent agent, and it autonomously decides whether I should call the tool or I should not call the tool. Okay, so I know we are implementing a weather agent, but let's say instead of implementing a weather agent, you had to implement some other agent. The style and the process is the same. Okay, so no hard coding. Everything is all dynamic and real time using a LLM. So hopefully this scenario is clear. This is an architecture diagram that basically showcases how these components will interact with each other. Let's look at this part first. So we have our AgentCore weather agent, and it essentially does dynamic tool discovery using AgentCore Gateway. So dynamic tool discovery is being done over here. So this is one part of our agent. Now, let me erase this ink. Now let us take a end-to-end scenario. There are two scenarios that we will discuss today. First is our user sends a prompt to our AgentCore weather agent. Our agent basically sends this prompt to our Bedrock LLM. And the LLM looks at the prompt and basically checks, hey, is weather info needed for me to respond back to this user's query or this user's prompt? There are two options over here. Yes and no. Let us first look at the no. So let's say if the answer is no, that is no weather information is needed, then the LLM creates a response to the user's prompt, sends that response to our weather agent, and then the weather agent basically gives that response back to the user. No weather tool calling, nothing. It's a simple, straightforward, hey, a LLM got a user's prompt, LLM worked on it, got the response, and sent the response back to the agent, and agent gave the response back to the user. Simple and straightforward. Now let's look at the second part of the scenario. Our user sends a prompt to our agent. agent basically forwards or sends this prompt to our Bedrock LLM. And let's say in this time the prompt was, what is the weather in Chicago? Now our LLM basically asks the same question. Is weather info needed for me to answer the question that is being sent by this user? The answer this time is going to be yes. So the moment LLM discovers that, hey, the answer is yes, it is basically going to send a signal to our weather agent saying, hey, tool call is needed. So essentially it is going to send a weather JSON to our agent. If it sends a weather JSON to our agent, then our agent will essentially understand that, hey, a tool call is needed over here. It then fetches the secret information. This secret is nothing else but our client ID, client secret, token URL, everything that is needed to basically fetch an OAuth token. So first it goes ahead and fetches all the secrets. It uses this secret essentially to fetch an OAuth token from Cognito. After it fetches the OAuth token, it takes the OAuth token along with the weather JSON, and our agent passes that to our gateway. Gateway basically understands that, hey, a tool call is needed. And it dynamically calls the weather tool, which is our Lambda function. Our Lambda function behind the scenes calls the OpenWeather API to fetch real-time accurate weather information. So hopefully this is understood until here. Now once it fetches information, it will send the weather information back to our Lambda function. Our Lambda function will send that information back to our gateway. Our gateway will again pass this information to our agent. And our agent will pass that weather info to our LLM. This LLM again will process the weather info, will basically see that, hey, using this weather info, can I now create a response to the user's prompt? And the answer would be yes. So it will create a response to the user's prompt, send that response back to our weather agent, and the agent will send that response back to the user. So this is how this entire flow works end to end, as is typically how it works in production as well. The most important or the most critical part of this entire workflow is this: the ability, okay, that is given to a LLM to basically decide dynamically whether to call a weather tool or not, when and when to call that weather tool. That decision is made by the LLM. Whether to call that tool, when to call that tool is made by the LLM. LLM basically makes that decision dynamically. That's the critical part. So there is no hard coding over here. So let's say if the user prompt was, what is the capital of USA? Then is where the info needed would be false or no. And this path would have been followed. So like this. Okay, so no weather tool calling is needed. If the user prompt was, what is the weather in Chicago? This entire path will be followed. That is a yes path. But let's say if the user prompt was, is today a good day for me to go sea surfing in Santa Monica? So now you see that I am not actually asking directly about the weather info. But sea surfing is a sport that is highly dependent on the weather. You can only go out sea surfing if the weather is good. So that's where your LLM kicks in. It basically checks, is weather info needed for me to respond back to this question? The answer is yes. So this entire process follows. That is creating the weather JSON, sending it to the agent, of course, the whole OAuth authentication, calling the gateway, Lambda tool, and a weather API. Finally, the weather info reaches to a Bedrock LLM. It looks at the weather info that it has received and then generates a response to respond back to the user looking at the weather, whether it is a good day to go sea surfing in Santa Monica or not. And finally, that response is sent to the agent, and the agent sends that response back to the user. So I hope that this is clear. This is not just about asking a direct question, what is the weather for this particular city, but basically asking LLM a question that may require an indirect weather input, basically for a specific activity that the user is planning to perform. So hopefully this is crystal clear, and this is what we are going to build today. So this is going to be slightly complex. We are going to basically use a lot of features that we have learned in the previous 17 parts, and this is going to be a fun lab. My 2 cents to all of you. Please practice this lab, okay? This lab is going to be very critical and very helpful to you, especially when you go out and give interviews, because this lab actually simulates how something is done in production. Let's say if I had to create a weather agent in production, I would use a similar architecture. It is the 80 to 90% over there. Of course, I would never say 100% because there are always options for optimization and improvement, but it is almost there. This is the architecture, this is the structure. You have the code in GitHub, everything is there. Okay, so practice this lab thoroughly, learn how this thing works, because when you go for an interview, they will ask you all of these questions as to how a LLM can take a certain decision dynamically. So hopefully this architecture diagram is clear. Let us now start with our lab. Our first step is environment setup. So we will provision an Ubuntu EC2 instance. Please ensure that it is ARM64 because this is going to be a Dockerized based agent. And if it is x86, your EC2 instance is x86, it will not work. There are workarounds to make it work, but all of those workarounds are very, very painful. So let's ensure that we start correctly with an ARM64 EC2 instance. This is going to be a T4G micro with 10 GB of disk space. I have created a script called as envsetup.sh. We will copy and create this script on this EC2 instance and then change its permissions and then execute the script. So let me quickly go here. This is my EC2 launch instance. This is one of the most critical steps, guys. Okay, that's why I'm showing this to you. So you go ahead and select Ubuntu over here, 24.04. Now you will get an option to select the architecture. Do not select x86. It has to be ARM64. And it will also give you a message to confirm the changes. Okay, so it's going to take a little while. I'm clicking on, there you go. Okay. Instance type is T4G micro. This is free tier eligible, so you are good. Select your key pair and make this 10 GB bytes. Okay, and launch instance. Now let us go over here and go to setup script. This is our environment setup, and simply just copy this entire script. Now I have my studio open. So let us look at the script. It is the same script that is there on GitHub, but here the contrast is better. So what are we doing in this script? We are basically performing some system updates, installing some core utilities, installing Python 3, virtual environment pip, installing AWS CLI v2. We're checking the version. Then we are installing and enabling Docker over here, checking the version for Docker. And finally, we are setting up Docker buildx for multi-architecture. One of the most important lines of this whole script is this line. Okay, we have to ensure that this at the end tells us that the platform is Linux ARM64. If it's not, then it's not going to work because this is going to be a Docker-based agent. Okay, so let me quickly copy this file. So Control C. And actually, did I connect to my EC2 instance? Oh, not yet. Okay, so let me first then connect to my EC2 instance. Okay, so copy this. If you want to modify the color, you can. I typically like because the contrast is really good. And finally, my credentials and open. Accept Ubuntu. Okay, clear the screen. And what we are going to do is env setup.sh, so vi, and copy our script from here. So Control C, right click, escape, colon WQ, hit enter. Now we need to basically modify the permissions on this particular file. So I'm just going to copy it from here. It's pretty straightforward. You can type it out as well. Okay. And finally, dot slash and this particular file. So we are going to execute this particular script for environment setup. So hit enter. And you will see that this entire script starts to execute. So we have completed step 1. Now, bear in mind that that particular script is going to take some time. So please be patient. The next step over here is to get Open API key. This is the key for our OpenWeather API. So you either need to have an existing account, then you sign in, or you create an account, go to the home page, and then click on Get API Key. And then you can click on API Keys. The key is typically like this. Now let me show you that. So, okay, it's probably hiding. There it is. Okay, so this is openweathermap.org. Okay, did it come in full screen? There you go. Okay, this particular site does tend to give some trouble. You see how my machine freezes? I don't know why it does that, but it does. For whatever reason, this new version of this particular OpenWeather map, it tends to freeze. Anyways, I have an existing login, so I'm logged in. If not, if you don't have one, just go ahead and sign up. The sign up is for free. Now, this is the home page. You go over here and you click on this orange button, Get API Key. So I'm going to click on that. And as I said, the site works a little slow. So you can see it's sluggish in nature, but it is what it is. We just have to live with it. Okay. But click on this Get API Key. And hopefully this thing moves ahead. See, it freezes my laptop completely. I don't know what's going behind the scenes. Okay, let's go ahead. Okay, everything else is working, but this thing is frozen. Okay. Okay, so this is the button that we need to click on, and then we can continue further ahead. Okay, so there it is. So after you click on that button, okay, again, it's frozen. You will basically land on this particular page. So as I said, just be patient. You have API keys right there, so click on that. Now, when you create a new account, by default, you will have a default key. This is my default key right here. And this default key is active. Now, since your account has been created, recently, or if it's a new account or you've just signed up, please be patient. It takes about 15 to 20 minutes for this particular key to get activated completely. Okay, so if I come back over here, so you see this is how the key looks like. This is my key. This is my default key. If you want, you can create or generate another keys as well. As you can see, I've created this one key over here. Like, okay, I'm going to remove this key and I'm going to say, hey, I'm going to create a temp key and generate. So you can also create a new key if you like. Now, how to test if your key is active or not? So there I have given this test open key API TXT. So go over here in your utilities and copy this particular URL. And now let's go back to our notepad and paste it right there. And this is my key. So I'm just going to copy it and simply put your key over here. Copy this entire URL, Control C, and basically paste it right there and hit enter. You see, I got a complete response for the weather in New York. So this particular key is active. But let's say, since I just created a new key, and you would pretty much have a similar experience if you just signed up. Let's say if I use my new key, copy, and now I test it. I go back up over here. I remove my old key, put this new key and hit enter. Now you see that I have got a 401. That's basically telling me that this API key is invalid. If you get this response, please do not worry. It's just that your key has not become active yet. As I said, it takes about 5 to 15 minutes, sometimes even longer. You saw that the site is sluggish for the key to become active. Okay, so I was just demoing you that this is how a 401 error comes. If you get this error, do not get discouraged in any way. Okay, so I am now going to close this. I'm going to close this and this sluggish site as well. So hopefully it closes. See, it doesn't even close. Okay, any which ways. Let's go back to our PowerPoint. So we have basically completed step 2. Now in step 3, we will create a secret for our weather API key. So we are going to use AWS Secret Manager or Secrets Manager. So we come over here, we type secret, and you'll get secrets manager right there. And this is where we will create our secret. So store new secret, and we are going to select other type of secret because this is a key, right? Like an API key. So if it mentions over here API key, OAuth token, or anything else. So this is an API key. And we are going to give this particular key name and our API weather key as the value. So OpenWeather API. Okay, now it is working. Let me quickly go over here and copy that. It's pretty simple. Okay, ensure that you stick to this name, please, because this name is being used in the source code. So OpenWeather underscore API underscore key. And now I will also paste my API key. So this is my API key. I had copied it earlier as well. It's the same key that we used earlier. So this is my API key. This key is the one that is active. And we will give it a key name. So we will say what? My weather API key. Let's give this name. Ensure that you copy the name. Control C. And over here, say secrets weather API key. And this is a secret name. Okay, I'm going to paste it over here as well in the description. Next, next, and store. So our key was created. View the details, and this is the secret ARN. So copy the secret ARN. Okay, and this is the secret ARN right besides it. Okay, so we have essentially completed step 3. Ensure that you use the same name. Okay, pause the video and use the same name. You can give any name that you like for the secret key. Ensure that you keep the name handy because you will use this name going forward. So we have created a key and our key value pair. Now we will go ahead and create our Lambda function. So this is going to be a Python function. We have a code in this particular file. Over here, we'll replace our weather API secret name and then deploy the Lambda. After the Lambda is deployed, we will change the Lambda's execution role. We have a JSON script, and in this, we will replace our weather API secrets ARN. Remember, we copied the name and the ARN. And then finally, we will test our Lambda. At the end, we will copy our Lambda's ARN and the execution role name. Okay, so let's go back over here. And now this is all created. So now let's go to our Lambda. This is our Lambda function right there. Click on create function. And we will give some name over here. So let's say my city weather tool, I'll give that name. Whatever, you can give any name that you like. Python 3.12. The architecture over here does not matter. Create function. Now, let me go to our GitHub, go to Lambda, and this is our Lambda code right here. Okay, so let us copy this piece of code. And we come over here, and actually I have the same code over here as well. But I am just going to paste it. What we need to do is replace our weather API secret name in this piece of code. So what was my name again? My weather API key. So copy and paste it right there. Ensure that your region is accurate. My region is US East 1. Okay. Otherwise, I'm also going to mention over here, replace with your region name. Okay, I'll just region. So that's more than enough. Okay, so we have everything replaced over here. And now we will basically copy this piece of code. Control A, Control C, and a lambda. Where is a lambda? This is a lambda right here. Ignore and Control A, delete, Control V. So we have copied our lambda over here. We are now ready to deploy a lambda function. So let's do that. So it's deploying a lambda function. So it's deployed a lambda function. Now we will basically create a small test. So create a new test event. We are going to say my test event. And we are going to remove all this and say city and give some city name over here. So let's say Boston. Okay, and save this. Do not invoke it right now. Remember, we still have to make changes to our Lambda role. So go to configuration, permissions, and over here you will see the name of your Lambda role. Okay, so copy this name first. Go back and Lambda. This is our role name right there. Okay, now let us go ahead and look at this role. We have to now basically add a custom inline policy for this particular role. So this is the name of our policy. So if you again go to your GitHub policies, and this is a Lambda API policy. If you see, it's a very simple policy. I'm just going to copy it, go back over here, add permissions, create inline policy, JSON, delete this and paste this. Remember, we have to replace with our weather API secret ARN. So now go back over here and copy our weather API secret ARN. So copy this and paste it right there. Okay. Next, we'll give a policy name. So my Lambda policy, create policy. Okay, the policy has been created. So we have completed this particular step. Now it is time for us to go ahead and test our Lambda function. So let's go back to the Lambda function. If you remember, we had created a test event over here. So this is test. Where is my test event? Okay, my test event is here. And let's say test. So it should basically execute the event or not. Okay, details. There it is. So this is our weather information. Let me zoom in a little. Okay. So if you see over here, our Lambda function was called, and behind the scenes, it has gone ahead and called OpenWeather API and fetched the weather information for Boston. That essentially means that our connectivity, okay, in this diagram that we were seeing earlier, right, in this diagram. So this connectivity between Lambda and the OpenWeather API, this particular connectivity has been set up. Okay. So this part is now working. We already tested that. Okay. So this is what is, this is the real information coming from OpenWeather API. Okay, so our test was successful. So time to move further ahead. So we finished this step. Now we will have to copy the lambda's ARN and the execution role name. I think we already copied the execution role name. So we will go ahead and copy our lambda's ARN. This is the ARN right there. So copy that and paste that right here. So step 4 is complete. Step 5. Now we have to go ahead and create a gateway and connect our gateway to our Lambda tool. So for that, we are going to go to AgentCore, Gateways, Create Gateway, give a gateway name. Remember to use JWT because we want OAuth. And we are going to use quick create configuration using Cognito. We will create a new service role. Please copy the name of that service role. Provide a target, my weather tool. You can give any target name that you like. Copy and paste our lambda's ARN. Define an inline schema. The schema is available in this particular file. And then finally go ahead and create our gateway. At the end, we will copy our gateway's ARN and URL. Okay, so let's execute these steps one at a time. Go back over here. So our Lambda is good. So we are good with this. So let's go back to AgentCore. So gateways, create gateway. So we will give it a name. So let's give my weather gateway. Okay. Use JWT, Cognito. These are the default, selections over here. Create and use a new service role. So copy this role name, Control C, go back to your notepad, say gateway, and paste it right there. Okay, scroll down, give a target name. So let's say or say get city weather. Any name, you can give any name that you like. Lambda ARN, and here we are going to paste our lambda's ARN. See, there is $latest towards the end. If you see, it's appended over there. Let that remain. Just replace your lambda's ARN before that. So copy and paste right there. In target schema, define an inline schema, and we will essentially import our schema from here. So go to gateway inline schema.json, copy the schema and paste it right there. Now, what was our tool name again? Okay, it is my city weather tool. Okay, so I'm going to give this tool name over here, plain text. So ensure that you replace it if it's different. Everything else is good. And click on Create Gateway. Okay. Now, if you see that there was an error creating target, if you see this yellow message over here. Now, off late, this has been happening for whatsoever reason with gateways. Okay, so don't worry about it. Our gateway was created successfully. But if you scroll down, you will not see any target. Simply just go ahead and click on Add. Okay, and just redo some of those steps. I don't know why, but it is misbehaving for some reason or the other. So we will basically just do those steps all over again and copy your inline schema and paste it right there. And of course, do not forget to replace your tool name. And I think this is good. Everything is looking good. Add target. So just redo the same steps again and you will be fine. Okay, as you see, a target was created successfully. Copy the gateway ARN and paste it right there. Copy the URL for our gateway, paste it right there, and the IAM role ARN as well. We have the role name, but we are also keeping the ARN handy. Okay, so all of that information has been copied from here. There are no role changes or anything for gateway, so we are good with step 5. Step 6. Now we need to go to Cognito and get client IDs and client secret, domain name. We will use this domain name to create a token URL and a custom scope. So now let's go to Cognito. And we will basically be able to see our user pool over here. This is my user pool right there. So go to app clients. This is your client and copy the client ID. Okay, so now create Cognito. This is my, okay, client ID. Now, along with that, I also need the client secret. So this is the secret. We also need the domain. We need token URL. That is something that we are going to build, and scope. Okay. So now for the domain, scroll down, go to branding, go to domain, and copy the domain from there. For token URL, we will build it later. Let us first go back to app clients, go to your client, and go to login pages, and copy your custom scope from here. And paste it right there. Now, to create a token URL, we need to take our domain and basically append it with this. Now, this is common for everyone, you, me, and everybody else. Okay. So simply take the domain name and add /OAuth2/token. So to create a token URL, copy this, paste it right there, /OAuth2/token. That's our token URL. And with that, we have completed step 6. Step 7. Now, remember that we want to fetch our OAuth token dynamically. And for that, we will have to store all of these values in our AWS Secrets Manager. We'll give it a secret name, and these are our keyword values. Ensure that you can give any name that you like, but ensure that the keyword values remain the same. Otherwise, you will have to go all over the code and replace these keyword values. Okay, so ensure that the keys are exactly the same. So now we will basically go back to our secrets manager, and I'm going to close this, and we are going to go to secrets manager. Okay, over here, we will create a new secret. So store a new secret. Other type of secret, so API key, OAuth token. Now remember, keep the same name. So client underscore secret. Client underscore secret. Underscore does not work on my machine, so I cannot type it that easily. Okay. Add a row. And then basically say client ID. And then you have token. Okay. Token URL. And finally, we have scope. Okay. So now we have to copy the required value. So this is the value of our scope. So let's copy that. Control C. Okay, where is that thing? Okay, Control V over here. Our token URL that we built. Paste it right there. Our client secret. So let's copy this. Client secret. And of course, our client ID. All of these have to be added and we are good to go. So click on next. Give a secret name. So what will we say? We will say my weather agent secret. Okay, let's give this name, my weather agent secret. I'm not sure if the secret name is there or not, but we will see. Next. And store. If the secret exists, then okay, it doesn't exist. Okay. And most importantly, always agent secret is this. And always remember to copy the secret ARN. This is the secret ARN, my weather agent secret. Okay. So we have stored these values successfully. So we have completed step 7. Now in step 8, we will create an Ubuntu EC2 instance role. So this is an EC2 instance role. We are going to associate all of these built-in policies and this custom policy. Remember to replace the gateway ARN in your custom policy. Finally, after the role has been created, we will attach this role to our EC2 instance, ensure that the role is active and attached, and we will do that using this particular command, get caller identity. So let's go back over here, go to IAM, and then go to roles. So roles, create role. Okay. Service type is EC2. Next. And we are going to say Amazon Bedrock full access. Amazon Bedrock. Okay, there you go, full access. Then we are going to say CloudWatch logs full access. And finally, Amazon ECR. Okay, EC2 container registry full access. Sorry, not ECR. Okay, next. Say my Ubuntu EC2 role. Paste it right there. And click on create role. Always keep the role name handy. EC2 role is this. Okay, so our role has been created. Now we will click on add permissions, create inline policy, and click on JSON. And this is where our policy is. So if we go back over here, go to policies, EC2 IAM role policy, this is there. Copy this policy and paste it right there. Now you will see that we need to replace our gateway ARN. So let's do that. So come back over here. This is the gateway ARN. Sorry, this is the role ARN. Sorry, my bad. Where is the gateway ARN? Sorry, this is my gateway ARN right here. So Control C and just simply replace this right here. Okay, and we are good to go. Next, give C my Ubuntu EC2 role policy and create policy. So our role has been created. Now we have to associate or attach this role to our EC2 instance, that is this, and then check whether it has been attached and whether it is active or not. So go to your EC2 and over here, select your EC2 instance. Okay, so your instance is running. Select your EC2 instance from here and then go to actions. Security, modify IAM role, my Ubuntu EC2 role, update IAM role. Okay, so our role has been attached to our EC2 instance. Let us just verify that real quick. Okay, clear. And sorry, where is that? Okay, there it is. So AWS, STS, get and get caller identity. So I'm just going to copy this piece. Okay. Okay, so our role has been attached, as you can see. So our step 8 is complete. Step 9. In a step 9, we will now go ahead and create our Docker agent. So first we will of course create an image for our Docker agent. So let's first create a project directory. Now the command to create the project directory has been provided. So if you go over here, go to AgentCore now, agentcommands.txt and mkdir copy and then create a directory over here. You can give any name that you like for the directory. I'm just going to use this, hit enter, and then change this particular directory as well. Okay. So this step is complete. Now we have to create our agent code. So app.py. The app.py has been given to you in your agent code right here, app.py. Okay, so I have the same code over here as well. Where is it? Okay, this is in Visual Studio Code. It's the same piece of code. Let us look at this code now. I'm going to, kind of go through this real quick. You can basically drill down in this code at leisure, but there are a few things that you should know while you are working with this particular agent. First is our logging level is warning. If you want, you can change this to info if you like. Then everything will be logged. Now, this particular agent uses 3 environment variables. First is AWS region. My region is US East 1. If your region is different, set it in AWS_region. So this is one of the first environment variable that we need to create. We also have 2 other environment variables, gateway URL and weather agent secret. That is a secret name. So we have to create a total of 3 environment variables. This is our model, our LLM. It is Cloud Sonnet 3. What are we doing over here? Remember, we have to fetch our OAuth token dynamically. So this is a function to fetch OAuth token dynamically. So we are getting our secret. Then these are all the values. And then we are essentially calling or fetching the OAuth token dynamically. After that, we are basically fetching over here. We have a function to fetch the tools or the tool listing dynamically as well. Finally, at the bottom over here, we have call gateway weather tool. Okay, and this particular, you can see the payload over here. So it simulates our JSON schema. And at the bottom over here, we are basically calling our Bedrock model. You can see that invoke model is right here. It is basically invoking that particular Cloud Sonnet 3 model. And this is your main invocation endpoint. Get OAuth token, weather tool, and all of that. Now, this part is absolutely critical. What are we basically telling our LLM? We are telling our LLM that you are an AI agent. If the user is asking for weather information, then respond only with JSON, and this is the JSON. Otherwise, respond with the actual response that needs to be provided to the user. So this is what we have over here, okay? And then if you scroll down, this is just in case city is not available, I've just put in New York City so that your code doesn't fail, okay? So otherwise, it's not hard-coded or anything. It's a dynamic fetch of the weather information. And you will see that you're basically calling the LLM again over here. And finally, we have some of our health points at the bottom, along with the run app. So I hope that, this particular app.py is clear. It's a little complex, but hey, that's how typical production workloads work. So we have our three environment variables that we have to create. So remember, AWS region, gateway URL, and weather agent secret. I'm going to copy this piece of code now, Control C, and then create our app.py. So go back over here, vi app.py, hit enter, hit I, right click, escape : WQ. So we basically copied and created app.py. Similarly, we are going to create our requirements.txt and our Docker file. So vi requirements.txt, and the code is available over here. We go to AgentCore, copy the raw file, escape : WQ. And we have to create our Docker file. So again, AgentCore, Docker file. Now I have the file over here as well. Okay, now let's look at this Docker file. The most important statement in this Docker file is this. If this statement is missing, your agent will not start or will not work. Okay, so we have to essentially copy this Docker file, go back over here, vi Docker file, I paste : WQ. Okay, and finally, I've created a deployment script. Now you need to replace your account ID and your region, and then use this deployment script. This deployment script will create an image or a container, an ECR container, and a repo, and push the container into this repo. Okay, so we will create a script, we will change its permissions, and then execute the script. So let's go to our script. So deploy.sh. So this is the script. Everything is ready. All that you need to do is replace your account ID and your region. So my region is US1. So I'm going to basically copy over here in our file region as US1. Now, as far as your account ID is concerned, you can actually go over here and copy your account ID. So copy your account ID. And now this script is ready to go. So Control A, Control C. If you want, you can change the repo name. Otherwise, just keep it the way it is. Okay. vi deploy.sh. I right click, escape :wq, and our deploy file is ready. Now we will have to change the permissions of that particular file. So let us do that. Control C. Okay. And then finally dot deploy.sh. And this will run the whole deployment script to create our image and our container. So hit enter. So with that, we have completed step 9. Now step 10. In step 10, we have to actually go ahead and create an AgentCore agent. So our script is running. So it's creating the ECR repository. As you can see, it's created the repository. It's pushing it to ECR, and our image has been pushed. So the container has been pushed. What you are going to remember is 3FE1. This is the latest container that was created. So now we will go ahead and create our agent. So we will give a name to our agent. We will select our container, our image, the latest image, and set these environment variables. And then we will update our agent's IAM row. There are a few replacements to make in that particular row. So let's go back and basically start with creation of our agent. So runtime, scroll down, host agent, and say my weather agent. You can give any name that you like. ECR container, browse images, weather agent, latest 3FE1. 3FE1. Okay, so this is the latest one. Select, copy the service role name always. Okay, so I'm just going to keep it over here. Agent role. There you go. This is the role name. Info, inbound, and advanced configurations. This is where we are going to create our environment variables. So click on add new variable, add new variable, add new variable. We have 3 variables. So what are those variables? We have gateway URL, right? What do we have? We have gateway URL, weather agent, weather underscore agent underscore secret. So there it is. And we have one last one is AWS region. We already know AWS region for me is US East 1. Weather agent secret. What is the name that we had given? My weather agent secret. So let's copy that and paste it right there. And the gateway URL. Control C and paste it right there. Host agent /2. And now our agent is being provisioned. Okay, so our agent was created successfully. See over here, it is giving me an option to update the IAM execution rule. Click on this particular option. And we will update our agent's IAM role with this particular policy. So let's go back over here. Agent code. Okay, go to policies and agent IAM rule right there. Copy this. We have a whole bunch of replacements to make in this particular file. Okay, so either you can, I think I have my code up as well. There it is. Okay, so just remove this and paste it right there. So the first thing that we have to replace is the account ID. So do that and go ahead, copy your account ID from, where am I going to copy it? Right there. Okay, there it is, account ID. Copied, paste it right there, replace all. The next thing that we need to do is replace our ECR repo ARN. So our ECR repo ARN has to be bought. So ECR, click on that. And there you will see our ECR repo where the agent. So select that or click on that. And then go to summary and copy your repository ARN. And paste it right there. And at the bottom, if you scroll down, you will see that you will need to replace your secret ARN. This is your weather agent secret. Okay, and I believe we had copied that earlier. And where is our weather agent secret? There is our weather agent secret ARN. Okay, so Control C and there it is. Okay, now this script is ready to go. So Control C and weather agent. I thought I was, oh, it disappeared. Okay, it disappeared on me. So now I will have to go to IAM. If it disappears on you, don't worry about it. Go to IAM, go to roles. Okay. And we had basically noted our agent role name. It ends with 4048F1. So 40, there it is. See? Come over here, add permissions, create inline policy, JSON, select this, paste it right there. Next, my agent policy, create policy. Okay, and our policy was created successfully. So we have replaced all of these and a policy has been created successfully. So now, if everything till now that we have done is accurate, then our agent should run and we are ready to test our agent. This is a sample that I've given. And you also have the sample over here. Okay. So if you go to agent code, you go to sample input, copy it. Now let's go back over here and say Bedrock AgentCore. I'm going to get rid of this. Go to your runtime. This is your runtime. Okay, so you have one version. Click on logs and you can start tailing. Click on start tailing. we are good to go. Okay, let's go back over here, select this test endpoint, and we will paste it right there. So we're going to start with something very, very simple. Okay. What is the weather in Chicago? Now click on run. Okay, so it's taking some time. So according to the weather data from OpenWeather API, the current weather in Chicago is broken clouds with a temperature of 23.72, which is minus 4.6 degree Celsius. It's winter. And this is coming from OpenWeather API. Okay, so what we did over here is we explicitly asked for weather. Now, if I go back to our picture that we started with earlier, okay, we have essentially asked for is weather info needed and executed this. But we asked for the weather. Okay, in this case, it was explicitly given to the LLM that, hey, weather info is needed. Now, let us ask a question that does not have anything to do with weather. What is the capital of France? Okay, click on run and it should give us the information. The capital of France is Paris. Okay, now let us ask something else. What explain AI to me? Okay, nothing to do with weather. Run and it should basically follow the no path, right? There's no weather, nothing over here. It's a very simple, straightforward question, and our LLM should be able to answer that question directly to us. And it's basically telling me everything about AI. Okay, now let us go back to our original prompt that we had given in our sample, right? So, is tomorrow a good day to go sea surfing in Santa Monica? Now, a question like this requires weather information, but that weather information is not asked explicitly. Our LLM will have to understand the user's prompt, understand the user's question, and determine if weather info is needed to answer this question or not. We all know that weather sea surfing is a weather dependent sport. Okay, so now let us see if it can interpret that, get the weather info, and then provide a response to the user. So click on run. Okay, so it says that unfortunately the weather data provided does not include any forecast information for tomorrow's conditions in Santa Monica. The data only shows this much. So see, it is actually telling you what is going on. The temperature is 59.63. To determine if tomorrow is a good day for sea surfing would need additional forecast details, such as wave heights, wind speed, etc. So it is asking for it, and this is the information that it has got. Let us now ask one more question. Is tomorrow a good day to walk around in New York City? Okay, so let's see what information it comes back with. Okay, so it seems that it was not able to complete this successfully for whatsoever reason. Now let us try something else. Is tomorrow a good day to go sunbathing in Tampa? We are trying to ask different questions. Let's see how this weather API works. Hopefully, at least it gets some data. There it go. It got some data for sunbathing. So based on the weather data provided, which shows temperature of 42.48, clear skies in Tampa tomorrow. Does not seem like an ideal day for sunbathing. Why? Because it's a little cold. Okay, so it's telling you it's not the best day. Temperature that low would make sunbathing quite uncomfortable and potentially unpleasant. So it's basically telling you, looking at the weather information, that this is not the best day for sunbathing. Sunbathing is typically better suited for warmer days, above 70 degrees or so. While the clear sky conditions are favorable, the cool temperature forecast for Tampa would make sunbathing inadvisable. Would be better to wait for a warmer day to comfortably enjoy sunbathing activities. Okay, so this is how you go about asking different questions. So maybe let's say, is it going to rain in Mumbai today? I'm just asking a question. Let's see what it has to say. Run. And it should be able to say, based on the weather data provided, there is no mention of rain in Mumbai today. The condition is listed as smoke, which is typically indicates hazy or smoky egg conditions. Okay, so it's basically it's telling you that, hey, it does not indicate, but additional information is not given, is unless additional information is given about a chance of rain, I can not definitively say whether it will rain in Mumbai today or not. So guys, I hope that this was helpful. Similarly, you can ask, like, hey, is it a good day to take a walk in Central Park tomorrow? I'm not saying NYC. Let us see if it can understand that the Central Park is in NYC. Okay, so let's run and see what information it can get. Okay, so based on the weather data provided, which shows 27.77, which is -2, clear skies in New York City, it could be a bit chilly, but not terrible for taking a walk in Central Park tomorrow. Clear skies are generally pleasant for outdoor activities. However, the temperature is quite cold, so you would want to dress warmly with a heavy coat. So it's basically telling you how to go about dressing, and then basically staying active by walking can help to keep warm as well. So you see, we did not even mention the city, we just mentioned a location, a park. LLM behind the scenes interprets everything, requests for the weather data by doing a tool call behind the scenes, and then formulates a response to the user's prompt, basically guiding the user accordingly. So guys, this is how an interactive weather assistant works, right? So if you ask a general question, it is going to answer a general question. If you ask for weather information, it is going to give you weather information. But if you ask a question that is dependent on weather information, then it is going to make that call, whether a tool call is needed or not, determine that, and then accordingly proceed further ahead. So if there are questions like this, which requires a tool call, especially a weather tool call, then a weather tool call will be done. The information will be provided back to the LLM, and the LLM will formulate the response. So as you see, it is basically guiding the user, saying that it's going to be chilly tomorrow and dress warmly. So guys, I hope that this lab was helpful. To practice this lab, to post your comments. If you're new to my channel, do like and subscribe and let me know. So, practice this. This is going to help you to even answer a lot of interview questions. Doing this end to end is very, very important. Okay, otherwise you will not learn. So Most of these services are free. Of course, you have to pay for the LLM. Nothing can be done about that. But, let me know your comments. And thank you very much. This is it from me today. And I will see you sometime later. Till then, take care. Bye-bye. Most importantly, don't forget to delete and release all the resources. This is the most important step. Please ensure that you delete all the resources. So with that, thank you and bye-bye.